So for the final part of this question, they are telling us that ball A bounces off the ground to a maximum height of 6.5 meters above the ground. And if we can recap here, we had in the first part that ball A was dropped from a height of 8 meters. We then found using a calculation that it is going to hit the ground with a velocity of 12.52 meters per second. And now we are being told that after it hits the ground, it will then bounce off the ground to a maximum height of 6.5 meters above the ground. And so for convenience, I will demonstrate this upward movement of the ball with this arrow. Okay, so the key information that they have given us here is that ball A is going to reach a maximum height of 6.5 meters above the ground when it bounces off, meaning that it will have a change in position which is equal to 6.5 meters during the upward movement. And now this is key because it is giving us a variety of information. Firstly, we know that generally the maximum height of a projectile is basically the peak height it reaches when it is moving upwards. And most importantly, we know that at that point, the velocity of the projectile becomes zero. So we know from the fact that this is a maximum height that the velocity of the projectile there is going to be equal to zero. And this is because this peak height here, or the maximum height, is a point just before the direction of the motion changes and the projectile starts to move back downwards. And the second thing that is worth noting in this situation is that although ball A was dropped from a height of 8 meters, when it bounces, it only reaches a maximum height of 6.5 meters, which is obviously lower than the initial height from which it was dropped. And so this is basically telling us that when it is hitting the ground, some of its kinetic energy is lost to other forms of energy. For example, it may be transferred to heat or sound energy. As a result, when it is bouncing off, it is not going to have enough energy to reach the height from which it was dropped. And so basically, this means that although ball A hit the ground with a speed of 12.52 meters per second, it is not going to bounce off the ground with the same amount of speed. And in fact, the first question now regarding this, which is 3.3, is asking us to calculate the velocity of ball A as it bounces off the ground. So they want us to find this initial velocity here. And so now that we have analyzed all of that information, we can actually try to answer this question. And so to do that, as usual, we can start by consulting our equations of motion to find a relevant formula to solve this problem. And so you can go over all of these equations of motion, but as you may already notice, this one here is our best option because we want the initial velocity, and in order to do that, we need the final velocity, of which we do have for this motion, and we also do have the change in position of the motion, and obviously the acceleration is just g. But if you consider the other three equations, you would need the change of time in order to use them. So this is our best option because we can just use all the information that we already have. And so, as usual, in order to do the calculation, the first thing that we are going to do is to choose our positive direction, and we'll just continue with taking downwards as our positive direction. And the formula that we are going to use is Vf squared is equal to Vi squared plus G delta y. We want to find the initial velocity, and you may already know what I like to do. So what I'm going to do is I am going to make this initial velocity the subject of the formula, even before I substitute in the quantities. So we will get that Vi is equal to the square root of Vf squared minus 2G delta y. And obviously, what I have done here is that I have taken G delta y to the left-hand side of the equation, and then I took the square roots of both sides, and then I just started the equation with Vi here. And so now that we have Vi in terms of Vf, G, and delta y, we can just substitute in all of those quantities because we know their values. So the final velocity, we know that it is 0 because that's the maximum height as we discussed. So we can scratch that one out, meaning that we will be left with -2 multiplied by G, which we know that is 9,8 meters per second squared. And it will be positive because downward is positive and the gravitational acceleration is always downwards. And then our change in position, we know that its magnitude is 6.5. And so since our projectile is moving upwards during this motion, it means that their change in position is going to be negative because we have chosen downwards to be positive, and the magnitude is 6.5 meters, right? And then using our calculators, the square root of -2 multiplied by 9.8 multiplied by -6.5 gives us 11.29 meters per second. And it's important to note that in this case, they asked us for the velocity, so we need to quote the direction as well. So this initial velocity here is the velocity at which this ball A, is bouncing off the ground. So as it bounces, it is moving upwards. And so the velocity will be 11.29 meters per second upwards, because a velocity is a vector quantity. So it's very important to include the direction in your final answer so that you can get full marks. And now the last question here says that sketch a velocity versus time graph for the motion of ball A from the moment it was dropped until it reaches its maximum height after the bounce. And they are telling us to include the following on the graph: the velocity with which ball A hits the ground, and the velocity with which the ball bounces off the ground. Okay, and so in order to do this, as we do with the calculations, even when sketching the graphs, it's important to indicate your positive direction, because the direction that you go with will also determine the shape of your graph. And so I will take here downwards as my positive direction, and we are sketching a velocity versus time graph. And then obviously the next thing is to draw your axis. And obviously you need to label your axes. As you may already know, on the x-axis we will have our time in seconds, and then along the y-axis we have velocity in meters per second, right? And now we need to consider the motion of ball A again from the point it was dropped up until it bounced off the ground. So at the start of its motion, meaning that at time equal to 0, the initial velocity was 0. So that point would be here, right? And now we know that from that point, since we have chosen downwards as our positive, the velocity of the ball started to increase positively, right? Up until it hit the ground with a velocity of 12.52 meters per second. So we know that at some point it will hit the ground, and when it does so, the velocity or the speed is going to be 12.52 meters per second. And that will be after some time t, which we had actually calculated. And so that point would be there. So now all that is left to do is to join these 2 points. Okay? And now thereafter, we know that after hitting the ground with this speed, it then bounced off the ground to a maximum height, right? And now the bounce is an upward movement, or it's an upward motion. And so if downwards is positive, it means that the initial velocity, which is the velocity that it bounced off the ground with, is going to be a negative velocity. And we know that from the previous calculation or from the previous question that velocity was 11.29 meters per second, as we indicated upwards. So it should be negative. And so it's going to be negative here, and it's negative 11.29. And we know that that is the velocity at which it will bounce off. So it means that we have a point here when it is bouncing off, and then after bouncing off, it is going to move upwards, right? And as it is moving upwards, it will move up until it reaches a speed of 0, because at the maximum height, the speed is going to be 0. So, for example, that would be a point maybe that is here. And then we just need to join these 2 points as well. And so there you have it. So now we can interpret our graph and see if it gives us the same information as we were given by the statement. So ball A started with an initial velocity of 0, right? And then its velocity started to increase as it was moving towards the ground. And then it reached, or it hit the ground with a speed of 12.52, right? At some time t. In fact, we did find what that time was. Here it is. The change in time for ball A was 1.28 seconds. And thereafter, we see that its motion changes because the sign of the velocity has changed to a negative. So here, since we have chosen downwards as positive, this proves that this was the downward motion because the velocities were positive throughout this motion. But now the velocity is negative, and that shows us that this must be when the ball was bouncing off the ground, right? And so it bounced off with an initial velocity of negative 11.29 that we found in 3.3. And so it moves upwards, and that is proven by the fact that this line here for this motion is below the x-axis, so it's negative, meaning that you have got negative velocity here throughout up until you reach the speed of 0 at the maximum height. And so basically that is how you can draw this graph. And so a question you might ask is whether, what if we had chosen upwards as our positive direction? And well, it's quite simple, because if upwards is our positive direction, then it would mean that when the ball is moving downwards, that is our negative direction. Therefore, this speed here at which the ball is going to hit the ground would be negative. So this 12.52 would be below the time axis. It would be around here. And likewise, it would mean that now the speed at which the ball is going to bounce off the ground will be positive. So this initial velocity would be positive here. And therefore, this 11.29 would be above the x-axis or the time axis. And therefore, overall, you would basically obtain a graph that is going to be this graph basically reflected about the x-axis, which are the time axis in this case. And so this is how that graph would look like. Otherwise, you would still follow the same procedure as we did before, but the only difference is that, for example, the speed at which the ball hit the ground would now be negative, and the speed at which our ball is bouncing off the ground would be positive. And as you can see, this graph here is just the graph that we had initially if we take downwards as positive, but just inverted about the time axis.